Good morning, algebra. So this morning we're going to talk about the difference between an arithmetic sequence and a geometric sequence. So we're going to take a look at this pattern that I have for you. If you look at the first picture that was given, you count the boxes, there are 6 boxes. And if you look at the second picture, there are 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. And then if you look at the last picture, there's going to be 12 boxes. So this is an arithmetic sequence because we're adding to get from one to the next. So what do I notice about the pattern above? It's adding 3 each time. So it would give me a plus 3. Okay? So now let's go over here and take a look at the geometric. The first, there is 1 coin, and then there's 3 coins, there's 9 coins. So this is clearly not adding the same number every time. This is multiplying by 3 every time. So a geometric multiplies. This one's multiplying by 3, so we would write times 3. Okay, so the difference here is that an arithmetic sequence is adding, or it can be subtracting. It can be subtract also, and geometric is only multiplying. So the next part are 2 formulas here that you're given on the final exam. This one here and this one here. So I'm just going to go through what those pieces of the formula actually mean. So A1 in this case represents the first term. So the first number we saw in the sequence. So if I go back up to my beginning sequence, it was 6, right? So 6 would go in that place. N is the number of terms I have. Okay, so if I'm looking for the 20th one, I would make N 20. D represents common difference. So how did we get from one number to the next? We added 3, right? So the common difference in the case up here would be the plus 3. Okay, and then AN represents the term we are looking for, or the term we need, or it could represent the last term, depending on the type of question they're asking you. Okay, so over here, if you noticed with the geometric, they're similar, but they're not all the same. So this still represents the first term. Your A1 is what you need. This is still your number of terms. And this is still the term you need. So whatever term they're asking you to look for, if they're asking you to look for the 100th number, then A sub n is the 100. But the R stands for rate, because in geometric we're multiplying. So if you notice in the geometric, the rate is in a parenthesis, because parentheses means multiply. Okay, and also the geometric sequence has an exponent, okay, because it's growing exponentially. So the first thing we're going to do is decide whether these sequences are geometric or arithmetic based on how do we get from one number to the next. So when I look at this first one, I get from one number to the next by adding 6. So because I'm adding, I'm writing arithmetic. Okay, that's all I want. So find the pattern. Okay, so this one, see how it's going from positive to negative, positive to negative? I must be multiplying. So I must be multiplying by -7. Okay, so this one is geometric because we're multiplying. Okay, now if I look at this one, I get from one number to the next, it's cutting it in half. So it's not dividing by 2. We don't ever divide. This is multiplying by a half. We're always multiplying, and this is also geometric. Okay. And then the last one, this one looks like it's subtracting 5, so that's arithmetic because adding or subtracting. So that's what I expected to see on this part. Okay, now the last thing we're going to be able to do is write an equation. So let's take a look at the other side. Okay, so if I'm going to write an equation for this sequence, I need to know a few things. A1, which is my first term, is 12. Okay, and how do I get from one number to the next? Well, it looks like again that it's multiplying by a half. So that means since I'm multiplying by a half, I know this is a geometric sequence, and I'm going to need the geometric formula. So no, I don't expect you to memorize this. That's why on everything you do, it's given to you. So I know that AN equals 12 times the rate we said was 1/2, the n minus 1. So that's all you do. I just plugged in the 12 and I plugged in the 1/2. So I took my first term and plugged it in, and I took my rate and plugged it in. That one's done. Okay, so over here, number 6, A1 is 10. And how do I get from one number to the next? I subtract 2. So I know this is arithmetic. Here's my formula. And no, we're not memorizing it. So we need a few more things here, and there's a little bit of work because we have to distribute. So n is going to stay n because we're looking for a formula, but d in this case was -2 because we said we were subtracting 2. So when we write a formula, we're going to leave the n and we're going to put 10 plus n minus 1 times -2. So all I need to do is distribute this -2 and simplify. So -2n plus 2. So an equals -2n plus 12. And that would be my formula for an arithmetic sequence. Okay, let's take a look at the next one. How do I get from one number to the next? Okay, so this one is taking away 5. This one's taking away 6. And this one's taking away 4. So when it's not constant, that's neither arithmetic or geometric, because even if I multiply, the pattern won't be a constant pattern. So this is neither, and we cannot write an equation. Okay, the last one has fractions, so don't let that confuse you because we're starting with 1. So we know that A1 is 1. And to get from 1 to a fourth, I must have multiplied, or think about it as you divided it by 4. So you must have multiplied by 1/4. And see if that works all the way through. If I multiply each of those by 1/4, yes, it definitely works. Okay, so that means my rate is 1/4 because I'm multiplying. So my geometric formula, and then I just fill in my A1 as 1, and I fill in 1/4 as my rate, and I leave the n minus 1 alone. Now, if they were to ask me for the 20th term, then that n would become a 20. But right now, we're just writing an equation. Okay, good luck.